Have you ever stopped and asked yourself a very simple question? What is software? It sounds almost too simple. We use software every day. We use software when we open an app on our phone. We use software when we write an email. We use software when we navigate somewhere with our car. We use software when we work with an industrial machine, and engineers might give a relatively straightforward answer. Software is code. It is a set of instructions that tells a computer what to do. Hardware is the physical part. Software is the non-physical part. That distinction has worked quite well for decades. But I have started to wonder whether this definition is becoming too narrow. Because something very interesting is happening with large language models and AI assistants such as ChatGPT, Gemini and Claude. And I think it could fundamentally change what we mean when we talk about software. Not because knowledge itself suddenly becomes computer code, but because software is increasingly becoming the interface through which we interact with knowledge. And that is what I would like to think about in this episode. Let's go back for a moment. Before computers became part of everyday life, how did we preserve knowledge? We wrote it down. We created books, manuals, scientific papers, encyclopedias, drawings, tables, equations. Libraries became enormous storage systems for human knowledge. And books are actually an incredible technology. A person can spend 20 or 30 years developing expertise in a subject. That person can then write a book. And somebody living on the other side of the world, perhaps decades later, can read that book and learn from that person's experience. That's extraordinary, but there is one fundamental limitation. The book is static. Imagine that I have a textbook about electrical engineering in front of me. I can read the book. I can look at its diagrams. I can study its equations. I cannot ask the book a question. I cannot say, wait a minute, I don't understand this paragraph. Can you explain it differently? The book cannot answer. I cannot tell the book. Please explain this concept as if I were 12 years old. And then 5 minutes later, now explain the same thing as if I were an electrical engineer. The book remains exactly the same. I have to adapt myself to the book. For centuries, that was completely normal. Knowledge was stored in a static form, and humans had to learn how to access it. Then computers arrived. And initially computers didn't fundamentally change this relationship. We digitized books, we created PDFs, we created websites, we created databases. Suddenly, instead of having thousands books in a library, we could potentially have 1,000 books on a computer. That was a massive improvement in storage and distribution, but something important remained the same. The information was still largely static. A PDF is incredibly convenient, but in some ways, it is still a book displayed on a screen. I still read it from the beginning toward the end. I can search for a word, I can copy something, I can zoom into a diagram, but the document itself does not really understand what I am trying to learn. And now, large language models are changing this relationship. Suddenly, I don't necessarily have to navigate through the knowledge anymore, myself. I can interact with it, I can ask questions, I can ask for comparisons, I can ask for examples, I can ask for a diagram, I can ask for an analogy. I can ask the system to challenge my understanding. I can say, I think I understand this concept, let me explain it to you, and you tell me where my reasoning is wrong. That is a completely different relationship with information. And this is where my original question becomes interesting again. What is software? Traditionally, we might have separated the world into categories. There is hardware, there is software, there is data, and there is a human knowledge. But these boundaries are becoming less obvious. I don't think we should simply say that knowledge itself is software. That would probably stretch the definition too far. A book is not automatically a computer program just because we scan it. But software can increasingly take knowledge and transform the way we experience it. And that distinction is important. Perhaps the revolutionary development is not that all knowledge becomes software. Perhaps it is that almost any knowledge that can be described digitally can now become interactive through software. Think about what that means. A written process can become a flowchart. A flowchart can become an interactive simulation. A textbook can become a tutor. A maintenance manual can become a troubleshooting assistant. A collection of engineering requirements can become a checklist. A scientific description can become an animation. A set of historical documents can become an interactive timeline. The underlying knowledge may be old, but our interface to that knowledge becomes completely new. Let me use an example from electrical engineering because this is an area I find particularly fascinating. Electricity is strange. We live with it every day, but we cannot directly see electrical current. We can see its effects. A lamp turns on, a motor rotates, a heater becomes warm, but the current itself is invisible to our eyes. And that makes electrical engineering quite abstract. If you study electrical engineering, you learn about voltage, current, resistance, capacitance, inductance, electromagnetic fields, and many other concepts. You learn equations, you draw circuit diagrams, you calculate, and eventually you build a mental model of what is happening. But building that mental model can be difficult. Imagine instead an interactive system. You have a circuit in front of you. You increase the resistance. Immediately, you see what happens to the current. You change the voltage. The visualization changes. You add a capacitor. You can watch the voltage develop over time. Then you ask, why did that happen? And the software explains it. Then you say, I still don't understand. And the explanation changes. Then you say, show me graphically. And it creates a visualization. Then give me a real-world analogy. And perhaps it compares electrical current with water flowing through pipes. Then you say, now stop using the analogy and give me the proper engineering explanation. And the system adapts again. The knowledge has not necessarily changed. Ohm's law is still Ohm's law. But access to the knowledge has changed enormously. And that could have profound consequences for education. There is another way I like to think about this. Human beings experience the physical world through our senses. Take a piece of wood. Wood is relatively easy for us to understand. You can see it, you can touch it, you can feel whether the surface is rough or smooth. You can compare two pieces and immediately notice that one is heavier. You can see that one is darker, you can feel that one is wet. You can try to bend it, you can smell it. The physical object gives us information through our senses. Abstract concepts don't work like that. You cannot put an organizational process on a table. You cannot touch a mathematical equation. You cannot smell a business strategy. You cannot hold an electrical field in your hand. You cannot directly see an algorithm. You need representations, words, symbols, charts, diagrams, equations. And this is where software can become incredibly powerful. Software can translate abstract knowledge into representations that are easier for us, for our senses and our minds to process. It can visualize, it can animate, it can simulate, it can speak, it can listen, it can react. And with AI, it can increasingly choose the representation based on the person who is trying to understand the concept. That last part is particularly important. Think about a traditional textbook. 1,000 people buy the same textbook. All 1,000 people receive essentially the same explanation. But those 1,000 people do not have the same brain. They do not have the same background. They do not have the same education. They do not have the same language skills. And they certainly do not have the same questions. One person understands something through equations. Another person understands it through pictures. Someone else needs an example from everyday life. And another person needs to understand the historical development before the technical concept makes sense. A static book cannot easily adapt itself to every reader. Interactive software potentially can. And that could make knowledge more accessible. Not necessarily easier in the sense that we no longer need to think. That would be a dangerous misunderstanding. Learning still requires effort. Understanding still requires thinking. Expertise still requires practice. But the interface between the learner and the knowledge can become much more flexible. And now let's take this idea outside engineering. Think about processes inside companies. Companies contain an enormous amount of abstract knowledge. How do we manufacture this product? How do we approve a change? How do we handle a customer complaint? How do we develop a new product? Who needs to approve which document? What happens if a supplier is late? Much of this knowledge exists somewhere, perhaps in a process description, perhaps in a PowerPoint presentation, perhaps in a quality manual, perhaps in an ERP system, perhaps in somebody's head. And often the challenge is not that the knowledge doesn't exist. The challenge is accessing it. Imagine joining a new company. You receive 50 documents. You receive links to several systems. There are process diagrams. There are instructions. There are presentations. And somebody says, here is everything you need. Technically, that might be true. But having information is not the same as understanding information. Now imagine a different interface. Instead of opening a 40-page process description, you ask, I need to introduce a change to this product. What do I have to do? The system explains the process. You ask, who needs to approve it? It shows you. What happens if the change affects software? The process adapts. Can you show me this graphically? A diagram appears. What are the biggest risks? The system highlights them. The process is no longer simply a document. It has become interactive. Again, I would hesitate to say that the process itself has become software. But software has become the interface through which the process is understood and perhaps even executed. And that is a major change. This also raises an interesting question about books. Will books disappear? I don't think so. In fact, I think books may become even more interesting. Because a book does something that an AI conversation does not necessarily do. A good book gives you a carefully designed path through an idea. The author decides, first, I want you to understand this, then I will challenge that assumption, and finally I will bring these ideas together. There is enormous value in that structure. When we only ask questions, there is a risk that we only learn what we already know to ask. A book can take us somewhere we didn't know existed. So perhaps the future is not books versus AI. Perhaps it is books plus interactive software. The book provides depth, structure, and perspective. The interactive system provides flexibility, explanation, and dialogue. One is not necessarily replacing the other. They may complement each other. There is also another important limitation. A language model is not simply a library that always retrieves the correct sentence from a book. It generates responses, and those responses can be wrong. They can oversimplify, they can misunderstand a question, they can produce information that sounds convincing but isn't correct. That matters enormously, especially in engineering. If I ask an AI system to explain a basic concept, an occasional mistake might be annoying. If I use an AI system to design something related to electrical safety, a mistake could have serious consequences. So the more powerful these interfaces become, the more important verification becomes. Maybe that is another change for engineers. In the past, a large part of engineering work involved finding information. In the future, perhaps more of the work will involve evaluating information. Is this answer correct? What assumptions were made? What standard applies? Where does this number come from? Can I verify? The ability to ask questions becomes easier, but the responsibility to judge the answers remains with us. And this brings me to something I find especially interesting about engineering. Engineers have always lived between the physical and the abstract world. A bridge is physical. But before the bridge exists, it is mathematics. It is calculations, it is requirements, it is drawings, it is models, it is assumptions. An electrical motor is physical, but its design begins with abstract concepts. A manufacturing line is physical, but behind it are processes, specifications, software timing, diagrams, and control logic. Engineering constantly transforms abstract knowledge into physical reality. Perhaps AI and modern software allows us to move in the opposite direction more effectively. We can take abstract knowledge and make it more visible, more interactive, more understandable, and perhaps that means more people can participate in technical conversations. You may not need to be an electrical engineer to explore what happens inside an electrical circuit. You may not need to be a programmer to build a simple interactive tool. You may not need to understand every mathematical equation before you can develop an intuition for a technical system. That does not eliminate expertise, but it may lower the entrance barrier to expertise. And I think that distinction matters. There is also an East meets West perspective here. Knowledge has always crossed borders. Books crossed borders. Scientists wrote letters to each other. Universities translated texts. Engineers moved between countries, but language has always created friction. Imagine an excellent engineering book written only in Chinese. If I don't speak Chinese historically, my access to that knowledge would be limited. Somebody would have to translate it. That takes time, it costs money, and perhaps nobody decides to do it. Now imagine systems that can translate, summarize, and explain knowledge almost instantly. Suddenly, language becomes a small barrier. A German-speaking engineer can interact with knowledge originally documented in Chinese. A Vietnamese student can explore material written in English. A Chinese engineer can discuss a Swiss technical document in Chinese. Of course, translation quality still matters. Context matters. Culture matters. Technical terminology matters. But the direction is fascinating. Knowledge becomes less tied to the language in which it was originally documented. And that could create entirely new bridges between East and West. Perhaps this is one of the most important aspects of this development. Software doesn't only automate work. It can mediate between people and knowledge, between languages, between disciplines, between levels of expertise, between abstract ideas and visual representations, and potentially between cultures. That is much broader than the traditional picture of software as lines of code executing instructions. The code is still there, of course it is. Computers still need instructions. Models still run on hardware. Data centers are physical. Electricity is required. Chips are required. Networks are required. So when we say that knowledge is becoming digital, we should not pretend that the digital world has no physical foundation. The cloud is still computers somewhere. AI still requires processors, software still needs hardware, but from the perspective of the person using the system, something important is changing. More and more of the abstract world can be become interactive. So perhaps we need to distinguish between three things. First, knowledge. Knowledge is what humanity has learned, discovered and documented. Second, software. Software provides instructions and systems for processing information and interacting with machines. And third, the interface between humans and knowledge. And I think this third category is where something revolutionary is happening. For centuries, one of our most important interface to knowledge was the page. Black letters on white paper. Then came the screen. And now we are moving toward conversation, simulation, visualization, generation, interaction. Maybe tomorrow, instead of reading about manufacturing process, you walk through a simulation of it. Instead of reading about an electric field, you see it around you through augmented reality. Instead of memorizing a mathematical formula, you manipulate the variables and watch the system respond. Instead of reading a 100-page manual before repairing a machine, you ask the machine's digital assistant what to inspect next. The knowledge may be the same. The experience of knowledge is completely different. And I think that is why the definition of software feels as if it is expanding. Software used to feel like something we operated. You opened a program, you clicked buttons, you entered information. The program executed predefined functions. Increasingly, software can feel like an environment in which knowledge becomes accessible. You don't necessarily need to know where the information is stored. You don't necessarily need to know which page contains the answer. You express what you are trying to understand. And the software builds an interface around your question. Sometimes that interface is text, sometimes it might be an image, sometimes a table, sometimes code, sometimes a diagram, sometimes a simulation. And perhaps eventually something we haven't even imagined yet. But I also don't want to end this episode by saying that everything will become software. The physical world remains physical. Wood remains wood, steel remains steel, food remains food, machines remain machines, human relationships remain human relationships, and human experience cannot simply be reduced to data. But the knowledge surrounding these things can increasingly become digital and interactive. And that difference is important. Maybe software will not replace the physical world. Maybe software will increasingly become a layer through which we understand the physical world. And perhaps that is the biggest transformation. So, let me return to the question from the beginning. What is software? What is code? Is it code? Yes. Of course, but perhaps that answer is becoming incomplete. Software is increasingly becoming something else as well. A translator, a simulator, a teacher, a visualization tool, a bridge between disciplines, a bridge between languages, and perhaps a bridge between human beings and the enormous amount of knowledge humanity has accumulated. For centuries we stored knowledge and asked people to go and find it. Now we are beginning to build systems that allow people to have a conversation with that knowledge. And that is a profound change. The future of software may therefore not only be about what computers cannot do or can do. It may increasingly be about what humans can understand. And for engineers, educators, companies, students, and really anyone who is curious about the world, I think that opens an extraordinary new chapter. Maybe software will not turn everything into code. Maybe it will do something much more interesting. It will take things that were once abstract, distant, or difficult to access, and give us new ways to see them, explore them, question them, and understand them. And perhaps in the end, that is one of the most powerful things software can do. Not simply execute our instructions, but help us interact with what humanity knows. Thank you for listening to East Meets Swiss. And until next time, stay curious.